Lab 13 is the second half of GPIO. Lab 12, if you remember, Lab 12, we use GPIO as the output. But in Lab 13, we are going to use GPIO as the input, and we are going to add some more interrupt. Okay, what is interrupt? We will learn about interrupt in chapter 7. Okay, and let's see. So we still use wiring pi as our library, but we need to set up wiring pi again. Why? Because we got the not the latest version of wiring pi. So please go to our classroom and follow the instruction again. Okay, we are going to download wiring pi version 3.14. If you recall, in our previous lab 12, we download 2.6 version. Okay, so it doesn't support input, but version 3.14 support the input pin, okay, and the interrupt as well. Okay, and we will install it here. This is download, this is installation. Okay, ready? Let's go back to lab 13 again. So we will use wiring pi ISR function. What is ISR? ISR stands for interrupt service routine. Okay, interrupt service routine. ISR. This function will tie a function name. This is a function name to the pin. Okay, and what kind of event that generates the interrupt. Okay, that will generate the interrupt. Let's see. In our event, there are 4 types. One is edge sensitive, falling and rising. Number 1 and number 2 are related to edge. What is an edge? What is an edge? This is our waveform. Okay, our input waveform. So we can, once we hit the push button, okay, the push button looks like this. It can generate a waveform. Once we unpush, we release. Okay, we release. This is push. Okay, this is push. This is release. Like this. So when you push the button, the voltage can go up to logic 1. Okay, and once you release, the voltage will go back to 0. Like this. and this is the edge. If you zoom in, this is the rising edge. This is the falling edge. Rising means it changes from 0 to 1. Falling means it changes from 1 to 0. Okay, that's called rising and falling. Is it okay now? Easy enough? Okay, and the third event happens on both. That means you hit and you release to check the both edges. Okay? That's called event type. Here, event type. And we will see in lab 13. Okay? So, in our circuit, it's a push button circuit. This push button looks like this. Okay, so look at it as a switch, and the circuit will, if you push, the switch will close and the signal can flow. Okay, if you release, what happens? It's open, so no signal. But in our circuit, this is the input pin. Okay, this is GND, ground. What is this pin? Pin number 1 is pin number 1. It's 3.3 volt. Okay, it's always give you logic 1. So that means here you get 1, and when you don't push, you get logic 1 here as the input to the BCM 2837. Okay, and this is what we call a pull up logic. It's called pull up logic because you always get 1 as the input. Okay, and when you push the button, what happens? The circuit connects to the ground. Okay, that means this pin will be 0. Okay, the circuit connects to the ground, so the logic will change from 1 to 0, and this gives us the falling edge. Falling edge. Okay, and in our source code we will connect pin number 0. Okay, pin number 0 correspond to this pin. Okay, pin number 0, that's GPIO 0. Okay, if you go back to lab 12, go back to lab 12. What is GPIO pin 0? here. Okay, so it corresponds to this. Okay, so be careful when you connect to the pin. Let's continue. Lab 13. So we introduce another variable called event count. It's a global and it has special type named volatile. Okay, special type named volatile, and this my interrupt function will be invoked. Okay, every time you by the interrupt pin, okay, which is our push button pin. Okay, and this function will add event count +1 again and again. If you push the button quick enough, within 1 second, every second. Okay, within 1 second, you can push the pin as many times as you want, and the event count will increase one by one. Okay, so as you can see, my interrupt is a function name. Okay, and it ties to this wiring pi ISR. Okay, so in our example, button pin is 0. The falling edge event. So every time you push the button, what happens? It will generate, this is the voltage or the logic to pin 0. Okay, so you get 1 at the beginning and 0 when you push the button here. So it causes the falling edge. And then when you release, you push here and you release here, the volt input will jump to 1. Okay, so every time you push the button, you cause the interrupt. Interrupt is something special like touch screen. Every time you touch the screen, it causes the interrupt to the CPU to respond to your finger, to your pen. Okay, every time you play the games, you tilt the cell phone like this. You play the game like this. Every time you tilt, it causes the interrupt. Okay, and so on. Like when you zoom like this, this is the response to your finger, to your interrupt. Your fingers can be responded like this or like this, zoom out, zoom in. Okay, so this infinite loop will print out the value of event count, the current value. And it will reset event count to 0 and delay by 1000 milliseconds or 1 second. So within 1 second, you can push the button, okay, and later, after that, the event count will be printed out and then reset to 0 again, and you push the button, okay, just like you are playing game, you push the up and down, you push the left and right arrow, okay, within 1 second, as many times as you can, okay. So this lab is so easy, but you have to be careful, okay. Why? Because you need a make file, okay, and I will how to use the make file. Go back to lab 12. If you recall, lab 12, we use GCC like this to compile and link to the wiring pile. Okay, link to the wiring pile. Okay, and modify this lab13.c. Okay, to be lab 13.c. Okay, I think lab 13 we have how many exercise? We would like to do lab exercise number 2 and exercise number 3. Okay, 2 and 3. That's pretty much it for lab 13. Okay.